Okay. So hi everyone. This is about Purescript, which is a strongly typed functional language that works nice in JavaScript ecosystem. If you have any questions, just stop me and ask straight away, because I might be going a bit fast, and so I want to make sure that everyone is up to what I'm thinking about. So what does strongly typed mean? You've seen the JavaScript what? Probably. You've probably seen a Python what, there's a PHP what, and so on. So they all exploit what happens to values of different types when they're coerced to each other, and how that can lead to strange behaviors that you didn't intend. So types of values, expressions, and everything tell us what is valid and what is not valid at a particular point in the program. And by looking at types can serve as tests, types can serve as documentation, and just generally help you. So here's an example from JavaScript. 1 is a number, ASDF is a string. 1 minus ASDF is not a number. A type of none is still a number. I'm not sure why is that. I honestly thought that would be an error, like 1 plus ASDF or something even worse. But this is not an error. It's fine. Types in Python. This is better. This is Python. So 1 minus ISDF is something bad. So that's right. We have a lot of tools that check that we don't write this nonsense. We have PyLint, we have MyPy, we have Flow, we have TypeScript. Who is familiar with Flow? Flow. I'm afraid Flowdog doesn't check types of anything. You can post any type of memes. Anyone familiar with TypeScript? If something that doesn't pass here passes TypeScript, I would like to hear about that, because I'm not very familiar with it. I tried Flow for a while. I'm familiar with PyLint and MyPy. So in the previous examples, Flow complains about 1 minus ASDF. That's not valid. PyLint is fine with this. MyPy complains about 1 minus ASDF. I didn't check TypeScript because I couldn't install it. And I ran out of time. So they're checking things, and they're more useful for objects and things like that. But that just gives us a point where a base point where we can compare this, and this is how types can be useful in the simplest expressions. But values like 1 or SDF are not the only things that can have type. So these are two functions. So the first function, which I call just double or something, it takes some kind of x and adds it together, adds it to itself. So what type would x be here? X can be a number, x can be a string. Can you override plus on JavaScript objects? I think you can override something like underscore value, and it will get you something. But let's say that no, that it's fine. And this is either a function from numbers to numbers or from strings to strings. As far as I know, Flow doesn't have this concept. I think PyLint does. For the sake of brevity, I'll only put examples in JavaScript for now. Like you can imagine Python examples being the same. What type does the next function have? What type do the arguments have? And what's the result? So f in here is a function. That's great. It's being applied to something in x. So x is an interval. Again, JavaScript can mean different things by intervals. Let's say it's a list or something else, probably. Python definitely does. But that's not really enough. F has to be applicable to the things that x contains. If f works on strings and x is a list of numbers, then nothing good will happen. Or f works on numbers and x is a list of strings. So I don't think any of those type checkers can express the fact that f and x must be linked in this way to be valid arguments to first matching. By the way, there is a bug in first matching, or not a bug, but something. Can you spot it? Maybe it's a bug, but I'm told that this works in JavaScript.
Oh, it's of.
Of. Okay, right. What happens if there is no matching thing? What's returned? Nothing. That means undefined, null. I think it's undefined. Yep. So if you rely on x being a list of integers, then you can't just say that first matching returns you an integer. It returns you an integer or undefined. So let's move on to a bit complex types. This is kind of flow syntax. So user has a name, which is a string, and the email, which is also a string. Actually, it should be string, sorry. And this is the value of the user. And it's all fine, but later on, we have to support anonymous users. And we decide to say that user can be anonymous as a string, or all of this. And again, I'm not aware of something that Flow or any other type checker in JavaScript can let you do, so that you can check that you've checked for anonymous everywhere and not just blindly said user.name and got something like welcome undefined. Will it get you welcome undefined? Or welcome null? Something like that. Same goes for Python, because sometimes you do pass objects in, and sometimes you have some kind of default values. An example of this is foreign keys in Django models, where you can pass another model, or you can pass a string named self, and that's a special case. And if you can't spell self, then no one will correct you, including Pylint. I don't actually know what will happen, but surely nothing good. Other thing, this is a function which takes a boolean and returns a boolean. Let's ignore the body for now. It's pretty obvious what it does. It inverts, you can reason that it inverts the value that it has. You can only ever write 4 different functions from boolean to boolean. But this is also kind of a valid function that you would expect to find and not give much thought to. So you had a user, and you pass where it should be an element or not, and you return whether it's successfully added or not. Have you seen something like functions like this in the code bases? I think they're pretty common, and they have side effects. So you can, in JavaScript, in Python, Pylint and everything will not restrict you from modifying other objects, writing to the console, making a AJAX request, talking to the database, and so on. And you really have no idea what happens inside the function by just looking at it and trying to guess what that user is, like trying to actually guess something about it. So this is the outline of kind of types and the problems in let's say object-oriented languages, or whatever you want to call them. And let's go and see what Purescript can offer to help you with all these problems. So this is a Purescript shell, and we can ask it about types of different things. So 2 is an integer, SDF is a string. If you try to add them together, you get an error message with a link to its wiki that explains what the error message means. When I paste more messages, I'll just abbreviate all this, but all of them have a reference to the wiki page that you can actually edit or submit pull requests to. That's pretty useful. If you tried any kind of functional languages like Haskell, then you might have seen like error messages would take half your screen and say something. Actually, C++ also goes here. and you have to figure out what's happening and what's the fix. So I find that pretty useful. We can have a list of things, arrays of things, but they have to be arrays of the same thing. We can have records of different things. So the type of author is a record where name is a string and friends is an array of string. If you say that you accept this, then you can't accidentally pass something else like anonymous or, I don't know, something without a name. You can rely on the fact that name is a string and friends is a list of string and so on. And so let's move on to functions. This is a function that computes, I think it even does it right, a diagonal of a right triangle. And here, functions also have types where you get the arguments, all the arguments, and the return value separated by this thing. So you give it a number, give it another number, and you get back a number. It might look strange, but let's just go with it for a moment.
So how do you differentiate between the return and the arguments?
The return is last. So the all but last things are the argument, and the last thing is the value. So that's actually a good question. What happens here? You don't need parentheses, you don't need commas, you don't need anything. You just say function and then list all the arguments and you get the value. What happens here is that you pass the first argument to it, then you pass the second argument to it, and then you get the result. So again, that's pretty straightforward, and Flow would have done the same thing. I think MyPy would also deduce the same thing. Let's look at this one. So it's a function of 3 arguments, the first of which is some function, and the second and the third have some type. So here the type is, for any kind of value, if the function returns me a boolean, then give me 2 of that thing that the function accepts, and I'll give you also a boolean. This is an anonymous function which says the argument is greater than 4. So you give here the type of this thing is an integer. And you apply it to 5 and 6, that's true. You apply it to 2 and 6, you get false. I could apply this both to something like string, and to produce something like, if both of strings start with an A, then it's true. If not, then it's false. So this function works for any type, like it is parameterized by type of A. It accepts a function. It accepts 2 of those things that the function accepts and returns a boolean. So another kind of type is, let's model that example with anonymous users. This is a sum type. Users are either anonymous or they are logged in users, and logged in users have names and emails. So let's say we want to greet the user and we want to just say welcome someone or just welcome if it's not anonymous. This is a function definition. You get to list the arguments and you can match what your arguments are. So heading for anonymous users is just welcome. Heading for logged in users is welcome plus, this is in Purescript, strings and numbers have separate addition operators because they're kind of like different things. There is no 0, and you can't, the minus doesn't make sense for strings, but the plus does, so it's kind of weird, and they just went and done another operator. So you can go welcome, username, exclamation mark. When you define this function, the compiler checks that you've matched all possible kinds of users, anonymous and logged in. If I would try to define only a heading with only the first line, it will say, this is not a valid function. You didn't match logged in users. If I forgot about anonymous users and just define this, it will say the same. You didn't define for the other kind of users. So if we have a user who is logged in with a name and email, we can call the heading function, and you get back the right gradient. Note that you can't just pass random things into heading function and expect it to work, because you have to pass a user. If you are promising to pass a user, like, you have to pass a user. That's it. One nice thing about JavaScript, like about Purescript, is it's written in Haskell, but you don't have to worry about that. Install any kind of compilers or like separate tools. You can just install it with npm. You can install libraries with Bower, which was a bit strange to me, like, why Bower, but it works. You can use it in Webpack straight away, and you can call JavaScript. You can call JavaScript from Purescript. You can call Purescript from JavaScript. That's all supported natively. You just literally write for and input that JavaScript function, and you get back, you can call it. And you compile Purescript code to JavaScript common.js modules, so you can just try them inside your JavaScript code. Moreover, since you know at compile time which functions are used and what, like statically, which functions are used where, you can eliminate pretty much all of the library code that you don't use. And so the resulting code, the resulting JavaScript code, is readable. If you've seen projects like PyPy.js, or even CoffeeScript started with it, but I think they changed it so they produce nice code. And of course, they have source maps now. But the point is that Purescript compiles to readable JavaScript. You can still see that your variables and everything are there, and it looks readable. How am I going for time? Any questions so far?
Yeah, you're about done with time, but keep going.
Sure. So I've started some examples here. Like there is a really nice book which goes into a lot more depth that I can in the talk, and I'll have a link in the rest of the talk. But here's one example of the sum types. So let's say you have the users who can be anonymous or logged in. The highlighting is kind of screwed, but whatever. And we want a function that gets us the username. We actually can't write such a function, because for anonymous users, we don't know what the name should be. So if we try to do that, this is not really what we should be doing. Instead, let's define another type, maybe, which is either nothing or just a value. So this type declaration says, my type maybe can be of something called A is either nothing or just that value of type A. I've seen this thing here. If you look here carefully, it's an array of integers. And so in the same way, you can define a maybe of integers, maybe of strings. So let's define getName, a function that takes a user and gives us a maybe of string. So getName for anonymous users is nothing. GetName for logged in users is that user's name. Well, that's great, but it just looks like more boilerplate for not much benefit. So let's move on and imagine that the users also have an address, only logged in users. The address can be a post office box with a number. Does it really have a number? Probably should be a string, but it doesn't matter, for example. or a street address with a city and street. So we want to try to get the city from the user. This won't get us anywhere because not all users have an address and not all addresses have a city. So we want a function from user to maybe city. Some users have a city, some users don't have a city. Oh, actually, sorry, this should be a string. Sorry for all the typos, it has been prepared today. So we have a getAddress function. That's just like the getName that we prepared earlier. We have a getCity function, which looks almost exactly the same, except here I don't care what the PO box number is, so I just put underscore. Underscore really means don't care. If there is a street address, then that's it. And let's combine them together. So I call getAddress and I call getCity. And we get an error. Why do we get this error? So the type of this is user. The type of this, what's the type of this? We applied the function from user to maybe address. This is getAddress. It was user. Now the type of this expression is maybe address. And we're trying to pass to getCity a parameter of type maybe address while it asks for an address. That's different. Again, sorry for the error message, it should be maybe address and address. So again, this sounds like a lot more boilerplate, and we can go and pattern match on, like this is called pattern matching. We can pattern match on nothing, just address, and do something else. But again, this is just more boilerplate for nothing. Let's write a generic function that takes a maybe value and a function like we had and gives us what we want. So this function, this is actually an operator. Operators are functions, like plus, minus, and everything else are functions. They just look differently, and they can be used between the arguments as opposed to in front of the arguments. So let's just write a new operator. If you have nothing, so let's imagine that we had an anonymous user. We got the address, which was nothing. And we're trying to get the city. The city, well, we can't really do anything else other than return nothing. But if we got the address before, and we got that function that we want to apply to it, then we can just apply it. So this is how we get the user city from a user without a lot of boilerplate. So we don't really care that any of these operations might not return us a value, but just nothing. We just write it like this, and it's fine. Again, you can probably do the same thing in Python. You can define a function that takes some value and takes some function, and if it's none or something like that, it goes and applies them or doesn't apply them. We can go further. Let's parse some dates. So we could just have a parseInt function, which takes a string and returns an integer. That's not really good because we might not have an integer. Let's have a better one. Take a string and return maybe an integer. Yeah, we could do that, but it would mean that instead of just saying when you give the function a string which is not valid, you just get back a nothing with no indication of what's failed. That's not really good. So let's define a new type, parsed, which is either error with some explanation. So for example, expected a number. Or it's a result of parsing that we got that thing that you asked for, you got that thing that you wanted to parse, and here's the rest of the string. So I think in JavaScript, parseInt will happily ignore the tail end of like spaces and everything. Will it actually ignore all the other things that not spaces after a number? I'm not sure. But here we can be explicit with it and say, well, here's your number, and that thing was after the number. So here's a parse integer, how it would look in Purescript, hypothetically. And let's imagine that we want to parse a date. A date is written or something like a date, which is written just like year, which is an integer, space, month, space, day. So let's define a thing that can parse us a space. That's kind of trivial, but just let's still do it. To parse, how do we check if our string has a space? There is a function that splits a string at some position, and we can see if it's something that we like. So the first one is space, and then the rest. Or it didn't split. Why didn't it split? Maybe because it was empty to start with, so we can't really split it. Or if this didn't match, then maybe it was split, but the first thing was not a space. So only if we get a structure which is like this, then we return a result with unit. Unit is the void type from C++, which again means just a thing, I don't really care. And this is the rest. And we get a nice error here. So how do we combine this and parseInt, which I won't write here? It turns out that we can combine them in the same way that we were trying to combine the maybe values earlier. If we have a parsed value and another function which tries to parse something and returns another value, then we can get that resulting value back. How do we do it? If we already have an error from parsing the first string, we can't do anything, it's an error. If we've parsed something and have a rest of, have the rest of the string here, we just apply the second thing that is parsing to the rest of the string, which will again return us a parsed value. So again, we'll get either an error or a result. So this is a pattern that you know that I named this thing the same, which is kind of like this. And this is a pattern which is very useful in functional languages, which can be used for, let's say, parsing like this, logging, for example, outputting something to console or somewhere else, or promises. Does anyone recognize a promise in this type? So a promise can also look like this, and you get back something like either you get back a result that you asked for, or you get back something else that you didn't ask for, and that's an error. And that's actually how the promises are implemented in Purescript too, with the same operator, going and chaining them. I think this is promise.then for in JavaScript. And so you can interleave all of your, you can use the same constructs to do different things. So for example, here we used it for parsing different things. Earlier we used it for dealing with something that might not be there with maybe values. So there is a lot more to Purescript. I just showed some basic things. There is a really good book taking you from the start of Purescript to building things like AJAX requests, and I think that they have some 2 applications, and it's really fantastic for like graphics in the browser. There are libraries for doing really nice graphics, which are pure, and you can reason about them with types and everything. And I've stolen a few examples from this post called Railway-Oriented Programming with this operator, which I also recommend. I had a link to my slides here, but it went somewhere, so I'll post it later on Flowdoc. But that's basically it. So, any more questions? I have tried to write a watch application for Pebble in Purescript. It went mostly all right. What didn't went right was the interface for actual uploading, for actual building the packages for watches was horrible. They used Webpack, and on top of it used something else. But the Webpack config was generated by something else, and in the end I gave up because they just couldn't. It wasn't just extensible enough. I had to generate JavaScript and pack that together with their vendor JavaScript to do anything. I'm planning on using it for some simple things like drawing the widgets and things. I know that it has bindings to React. It has some libraries which try to imitate React. And it has good graphing libraries, like for drawing, diagrams. So yeah, that's it. I didn't write a serious thing in it, but I think it works for stuff like it can replace, there's a library that can replace basically Knockout. The interface is almost the same, but it enforces things like the Angular and React. I think they try to warn you, but don't actually enforce it, that you can't mutate the state while you're rendering. While here with the types, you can just say that you return an HTML fragment, and that's your new component. And you can't modify the state inside because the function is pure, so you can't even do it. And so you can be sure that whatever your component is doing, it's not doing any nasty things.
How does Elm relate?
Elm relates to this. I wasn't sure which one to present with. I tried a few things in Elm and Purescript. They are very similar. It's so similar that almost all of these examples will compile basically unchanged. Elm takes a super minimalist approach where it just gives you basic unit operators, and they are forcing you into a particular application model where you I think they're just trying to imitate functional reactive programming. So that you have a number of events, and then of events you render a new component, and Elm is smart and will replace only the bits that are changed. This is really nice, but if you start doing any kind of more interesting things, then Elm approach starts to be a little bit limited. It might be easier to learn. So if you find Purescript has too much concepts, try Elm, which also has a good tutorial here. which walks you through a creation of example, like a nice form example and some AJAX requests and some other things. They both compile to JavaScript and everything.
There's no more questions.